Hi, let's continue curve sketching. This is example 1. It's polynomial, very simple polynomial, degree 3, y is equal to f of x. We try to sketch this curve. Now this curve is not periodic. This function is not symmetrical function, and the domain is from the domain of function is all real numbers. The range is all real numbers. Therefore, this is a graph we try to sketch from minus infinity to positive infinity, and nothing else. So we just sketch the whole thing, and then we're looking for what? We're looking for, say, y-intercept. Y-intercept, right, is equal to 2. So that is 0, 2 is the point. We know it. Then derivatives, dy dx. dy dx minus 15 minus plus 18x minus 3x squared. And then we simplify by taking 3 out, negative 3 out, negative 3, and then we can have a, let me simplify the function. This is x minus 1, x minus 3. Well, this is nothing but simple differentiation and plus the simplification of the algebra, and then we have this. So the reason we put them in the factor is because we want to find the critical points. So the dy dx equal to 0 will give you x equal to 1 and x equal to 5. So these are critical points. It may be maximum, maybe minimum. And then we're looking for a second derivative. This is equal to 18 minus 6x, right? Which is equal to 6, 3 minus x. Yeah. So this is the second derivative. Then the second derivative equal to 0 will give you x equal to 3. Means that these 3 points are important. These 3 points are critical, and we should analyze with them. So I put these 3 points into a table. How many points? 3 points. 1, 2, 3, and the other 4 subintervals. This is x. This is from this is 1, 3, 5. These are 3 critical points, and divide the whole interval into 4 subintervals. Minus x minus infinity to 1, and from 1 to 3, and from 3 to 5. From 5 to infinity. Okay. Then we calculate the derivative, first derivative, the second derivative, and then y, the function of y. And we can sketch the curve. All right. Here. Now, in this interval, the first derivative is what? Is this one. So we try to calculate not the value but the sign, because the sign determines the shape of the curve. We're not necessary to find the the value. So let's take any point between any point in this interval. Say take 0, because easy to calculate. For 0 here, you get negative. So this is negative, right? When x equal to 0 or 1 is 0. Here I choose 2 to test. 2 here. This is positive. This is negative. And negative again is positive. So this is positive. And here is x equal to 3. Positive, negative, positive, positive. And here I choose 4 to test. This is negative, positive, negative, that becomes positive. 5 is 0. And here I choose, say, million. And this is negative. Right? Then I do the second derivative here. I choose 0 to test. 0 here is positive. X equal to 1 is positive. X equal to 2 is positive. X equal to 3 is 0. X equal to 4. X equal to 4 is negative. X equal to 5, negative. X equal to a million, negative. All right. Then we use with this dictionary. Second derivative is positive. Second derivative is positive. Second derivative positive, first derivative negative. So this is the shape. Right? This is the shape. And second derivative positive, first derivative positive. This is the shape. And second derivative is negative. Second derivative is negative. This way. First derivative is positive. So this is the shape. First derivative, second derivative is negative. First derivative is negative. So this is the shape. Alright? Obviously that this is minimum, right? Minimum, yeah. And obviously this is the maximum. And obviously this is point inflection. Because increasing like this, increasing another way. It's point inflection. So far as the value concerned, and you just put there, right? So this f of 1, you plug the value here, is equal to minus 5. So this is minus 5. And f of 3, you replace 3 here, plug 3 here, you find the value which is equal to 11. And f of 5, you plug the value into polynomial. So this is equal to 27. 27. Then finally we join all the pieces of information into a picture. Yeah. This is y, this is x, this is 0, and 1, 3, 5. Right? 1, 3, 5. No, it's not good. 1 is here, 2, 3. 1 is here. 1, 2, 3, 4, 5. Sketch is something rough. 1 is 3. Right? Sketch is something which is a rough drawing, but does not lose the generality. The picture has to be reflect the feature of the function, but not very exact. This is minus 5, so minus 5 here. This is minus 5. Vertical could be different scale, minus 5. So this is the point. Yeah, this is the point. And the 3, 11. 311 is, this is 5, 10, 11, somewhere here. This is 11, right? This is 10. And then 5, 27. 20 is here. 27 somewhere here. This is Alright, and the plus the y-intercept. Y-intercept is 2. And this is 5, this is 2 somewhere here. This is 2, right? Then combine all these, connect these curves, points by using these shape curve. From infinitive to this point, passing through the intercept is this shape, So we have this, right? And this is shape. Excuse me for the and then go to this point, 311, using this shape, and this is right. Be careful, the gradient must be 0 here, the tangent. The tangent 0 must be here. Therefore, the curve must be smooth. Don't use sharp angle. There's no sharp angle. Sharp angle does not exist. Then from this point, 311 to 527, have this shape. This is the shape. Yeah, this shape has to be smooth. Huh? Then finally, this is the shape, right? Okay. Well, this is the curve function.